of the 2025 internal pure chemistry paper 2. So without any further ado, let's look at question number 1. So question number 1 reads, so this question is all about safety, particles, and diffusion. So part A asks us to give 2 safety precautions to be taken when carrying out an acid-base titration. So titration involves the handling of acids and alkalis, which can be corrosive, so safety is always matters here. 2 good precautions are wear safety goggles to protect your eyes from splashes and wear a lab coat. Alright, so moving on to question B, question 1B. So question 1B tells us that particles in the states of matter are always moving. Particles in a state of matter are always what? Moving. But B1 asks us which theory supports this fact? Which theory supports this fact? So the answer is the kinetic theory of matter. So this theory explains all particles, whether in solid, liquid, or gases, are in what? Constant motion, and the amount of energy they have determines how they move. Alright, so moving on to question B2. So question B2 asks us to describe the type of movement of particles in solid. Describe the type of movement of particles in solids. So in a solid, particles are held closely together in a fixed positions, so they cannot move from place to place. Instead, they vibrate about their fixed position. That's a key word to remember: vibrate and not move freely. Okay, moving on to question C. So question C is all about diffusion, since gases diffuse at different rates. So let's look at question C1. So question C1 asks us what is meant by the term diffusion. What is meant by the term diffusion? So diffusion is a movement of particles from a region of higher concentration to a region of lower concentration until they are evenly spread out. This happens because particles are in constant random motion. Alright, so moving on to question C2. So question C2 gives us a practical scenario. Gases A and B are colorless, but react to produce a yellow band, which is a solid. We are told the relative mass of A is double of that of B, and we need to show on the diagram where the yellow band would form. So here, how to think about this is step by step, is that light gases diffuse faster than heavier gases. Since gas B has half of the molecular mass of gas A, gas B is lighter, so it diffuses faster and travels further before meeting gas A. So this means that the yellow band will form closer to the source of gas A, not in the middle of the tube. So when you are marking this on the diagram there, the place where the yellow band should be near to the source of A, because B has traveled further to meet it. So that completes question A1 with 6 marks. Let's move on to question A2. So question A2 reads, so question 2A2 shows us a diagram of an experiment for separating mixture Q, where the mixture is heated and passed through an apparatus before being collected rather. So part A asks for the name of the separation technique shown in the diagram. So looking at the setup there with a heating, a condenser, and a collection vessel, this clearly shows that this is what? A simple distillation. So that's the answer. The setup there shows what? A simple distillation. Okay, so but moving on to part B. So part B asks us to name the apparatus A and state its function. So the apparatus A, the piece with the water flowing through it, is called a condenser, and its function is to cool the hot vapor so that it condenses back into a liquid, which can be then corrected. Okay, moving on to question part C. So part C asks us to label the water inlet and outlet on apparatus A. So the rule here is that the water always enters at the bottom of the condenser and leaves at the top. This is so that the condenser fills completely with water, giving the most efficient cooling, working against gravity rather just running straight through. Okay, moving on to question D. So question D reads, give one industrial use of this separation technique. give one industrial use of this separation technique. Okay, so a great example is a distillation of sewer water to produce fresh drinking water, or the refining of crude oil through fractional distillation, which works on the same cooling and condensing principle. Okay, that's question A2 done. 5 marks, just like that. Now let's move on to question A3, which deals with the atomic structure. Okay, so question A3, part A asks us to complete the table to deduce the number of electrons and the number of neutrons in two ions given, namely the nitrogen ion and the gallium ion. So let's work through the nitrogen first. So the bottom number 7 is the proton number, which tells us that nitrogen normally has 7 protons and 7 electrons, but this is an ion with a 3 minus charge, meaning it has gained 3 extra electrons. So the number of electrons is 7 plus 3, which gives us 10 electrons. So the neutrons will take the mass number 15 and subtract the proton number 7. 15 minus 7, this will give us 80 neutrons. Now for gallium. So the gallium, the proton number is 31. So gallium normally has 31 electrons, but this ion has 3 plus charge, meaning it has lost 3 electrons. So the number of the electrons is 31 minus 3, which gives us 30, which gives us 28 electrons. So for the neutrons, we take the mass number 71 and subtract the proton number 31. 71 minus 31 gives us 40 neutrons. So to summarize, the nitrogen 3 minus has 10 electrons and 8 neutrons, and the gallium plus has 28 electrons and 40 neutrons. Then we're moving on to question B. Question B asks us to draw a structure of the nitride ion showing all electrons. So nitrogen has 7 electrons normally, arranged as 2 in the first shell and 5 in the second shell. As 3 minus ion, it gains 3 more electrons, giving a total of 10 electrons, arranged as 2 in the first shell and 8 in the second shell, which now is a full outer shell, just like neon. When drawing this, show the nucleus with the symbol N and the charge 3 minus, with two electrons in the inner shell and 8 electrons in the outer shell. Often shown, and most of the time this is shown as dots and the crosses to represent the original and the gained electrons separately. That's question A3, 6 marks. Okay, let's move on to question A4, a calculation question. A calculation question. So question A4 tells us that Elena reacted 0.765 grams of aluminum oxide with 100 cubic centimeters of 0.1500 moles per cubic decimeter of sulfuric acid and collected 1.368 grams of aluminum sulfate. A asks us to construct a chemical equation for the reaction, including state symbols. So aluminum oxide reacts with sulfuric acid to form aluminum sulfate and water. Let's balance this step by step. We start with aluminum oxide, which is Al2O3 plus sulfuric acid, which is H2SO4, reacting to form aluminum sulfate. Al2 open bracket, so open bracket SO4 close bracket 3 plus water, which is H2O. To balance it, we need 3 sulfuric acid molecules to provide the 3 sulfate groups, and that gives us 6 hydrogen atoms, which form 3 water molecules. So the balance equation is Al2O3 plus 3H2SO4 will give us Al2 open bracket SO4 close bracket 3 plus 3H2O. Adding state symbols, aluminum oxide is solid, sulfuric acid is aqueous, aluminum sulfate is aqueous, and water is liquid. Then moving on to question B. So question B asks us to determine the limiting reagent in this reaction. Determine the limiting reagent in this reaction. So it's here. So here's how we approach this step by step. First, calculate the moles of aluminum oxide. The relative molecular mass of air, Al2 or 3 is 27 times 2 plus 16 times 3, which gives us 102. The moles equation, moles equals to mass divided by molar mass. So 0.765 divided by 102 gives us approximately 0.0075 moles of aluminum oxide. Next, we calculate the moles of sulfuric acid. Moles equals to concentration times volume in cubic decimeters. The volume is 100 cubic centimeters, which is 0.1 cubic decimeters. So moles equals to 0.1500 times 0.1, which gives us 0.015 moles of sulfuric acid. Now compare this to the equation ratio. From the balance equation, 1 mole of aluminum oxide reacts with 3 moles of sulfuric acid. So 0.0075 moles of aluminum oxide would require 0.0075 times 3, which is 0.225 moles of sulfuric acid. But we only have 0.015 moles of sulfuric acid available, which is less than what's needed. This tells us that sulfuric acid is a limiting reagent because it would run out first. Moving on to part C. Part C asks us to calculate the percentage yield of the product. Calculate the percentage yield of the product. So first we calculate the theoretical yield based on the limiting reagent, sulfuric acid. From the equation, 3 moles of sulfuric acid produces 1 mole of aluminum sulfate. So 0.015 moles of sulfuric acid would produce 0.05 divided by 3, which is 0.005 moles of aluminum sulfate. The molar mass of aluminum sulfate, which is Al2 open bracket SO4 close bracket 3, is 27 times 2 plus sulfur 30, 2 plus oxygen 16 times 4, all multiplied by 3, giving a total molar mass of 342 grams per mole. The theoretical mass equals mass times molar mass. So 0.005 times 342 gives 1.71 grams as the theoretical yield. So the percentage yield is equals to actual yield divided by theoretical yield times 100. The actual yield given was 1.368 grams. So 1.368 divided by 1.71 times 100 gives us approximately 80%. That's question A4 complete. 8 marks in total. Now let's move on to question A5, which uses the periodic table. So question A5 part A is about group O elements, which include helium, neon, argon, and krypton, and xenon. So part A1 asks for the common name of these elements, and these elements are called the noble gases. Part A2 asks for one use of helium. Helium is commonly used to fuel the balloons and the airships because it's much less dense than air and is non-flammable, unlike hydrogen. Okay, moving on to question A3, which asks us to explain why these elements are monoatomic. Noble gases, why these elements are monoatomic. So listen closely. Noble gases exist as single atoms because they are already have a full outer shell of electrons. This means they are extremely stable and unreactive. So they have no tendency to bond with other atoms or even with each other. Alright, so that's the answer there. Then moving on to question B. Question B tells us that the transition metals are found between group 2 and group 3 of the periodic table. Then part B1 asks us what type of oxide these elements form. So transition metals form basic oxide through, though some can be amphoteric depending on the specific metal. Then move on to part B2, which asks for the two properties of transition metals. So the good answer, or the good answers may include they have high melting, they have high melting and boiling points. They are good conductors of heat and electricity. they form colored compounds, and they often show variable oxidation states. Any of any two of these will earn the full marks. So that's question A5 finish, 6 marks. Now let's look at question A6, which is about the displacement reaction. So question A6 tells us that aqueous bromine reacts with aqueous potassium iodide in displacement reaction. So part A asks us to construct an ionic equation for this reaction. So let's build this step by step. Bromine is more reactive than iodine, so bromine displaces iodine from the potassium outside. In ionic terms, we only show the spaces that are actually changed. So bromine as Br2 gains electrons from the iodine ions, which loses electrons to become iodine. So the ionic equation is Br2 plus 2I minus C. We give us 2Br minus C plus I2. Notice the potassium ions are restricted ions and are left out of the ionic equation entirely. Okay, moving on to question B, part B. So part B asks us to state and explain one observation made during this reaction. So question B asks us to state and explain one observation made during this reaction. So the observation is that the colorless or pale yellow bromine solution changes to brown solution, or you might see the solution turn brown or dark orange. The explanation is that iodine is being formed in solution, and iodine gives a brown color aqueous solution. So moving on to question C. So question C asks us to explain how an increase in temperature increases the rate of this reaction. Here's a step-by-step reasoning. When temperature increases, the particles gain more kinetic energy, so they move faster. This means particles collide more frequently, but more importantly, a greater portion of particles now have energy equal to or greater than the activation energy. So a higher percentage of collision result in a successful reaction. Both of these effects combine to increase the rate of reaction. So that's your answer there. Then moving on to part D. So part D asks us to state whether the bromine is oxidized or reduced in this reaction. So looking back at our ionic equation, the bromine starts as Br2 with an oxidation state of 0 and ends up as Br minus with an oxidation state of -1. Since its oxidation state decreases, bromine has gained electrons, which means bromine is reduced. And that's question A complete, 7 marks. I hope you are learning one of the things. Please, if you haven't subscribed, do so. If you haven't liked, please do so. If you haven't comment, please do so. If you haven't joined our online classes, please do so by WhatsApping me on the number shown on the screen there. All right, so let's move on to question 7. Okay. So question A7, aqueous silver nitrate AgNO3 in aqueous solution is electrolyzed in inert electrodes. Part A asks us to write the formula of all the ions present in the electrolyte. So silver nitrate becomes into what? Silver ions Ag positive and nitrate ions as NO3 negative. But this is an aqueous solution. Water itself is also partially ionized, giving us hydrogen ions H positive and hydroxide ions as HOH negative. So together, the four ions present in a Ag positive, the four ions present are Ag positive, NO3 negative, H positive, and OH negative. Don't forget that the water derived ions, they are easily missed out but are required for the poverty marks. So always know that if something is aqueous, always add the hydrogen ion and the hydroxide ions. Okay, moving on to question B. So part B asks us to construct chemical equations including set symbols for the electrode reaction. Okay, asks us to construct chemical equation including set symbols for the electrode reaction. So part B1 asks for the cathode reaction. So the cathode is the negative electrode, where positive ions are attracted and gain electrons in a process called reduction. We have two positive ions variable. We have two positive ions available. silver and hydrogen ions. Since silver is less reactive than hydrogen, silver ions are discharged in preference, meaning that they are discharged first. So the equation is built like this. One silver ion in aqueous solution gains one electron to form one neutral silver atom deposited as a solid written out. Thus, Ag positive aqueous plus Me minus giving us Ag solid. That's how I write the equation there. Then part B2 axis for the anode reaction. Part B2 axis for the anode reaction. So the anode is a positive electrode where negative ions are extracted and lose electrons in a process called oxidation. We have two negative ions available, nitrate and hydroxide. Nitrate ions are very stable and are not discharged. So hydroxide ions are discharged instead. So hydroxide ions are discharged instead, releasing what? Gas, releasing oxygen gas. The equation step by step is that 4 hydroxide ions in aqueous solution lose 4 electrons, forming one molecule of gas of oxygen gas and 2 molecules of water, written out as 4HO negative, the negative charge in aqueous state, give us 2 oxygen gas plus 2 H2O liquid plus 4 E minus. That's right. That gives us question A7. That gives us the answers for question A7 and the 6 marks. Now let's look at question A8, our final question in section A. So question A tells us that the sodium, potassium, and rhodium and rubidium are some of the elements found in group 1 of the periodic table. So part A asks us to give a reason why they are all found in this group despite having different atomic numbers. The reason is that they all have one electron in the outermost shell. Elements are grouped according to the number of electrons in their outer shell, not according to their atomic number. So part B asks us to explain why potassium is more reactive than sodium, despite being in the same group. So here the answer is that potassium has one more electron shell than sodium, which means its outermost electron is further from the nucleus. Because it's further away, the attraction between the nucleus and that outer electron is weaker due to increased shielding from the extra inner shells. This means the outer electron is more easily lost in potassium than in sodium, which is why potassium reacts more vigorously than sodium. Okay, moving on to question C. So question C reads, Construct, construct a balanced chemical equation for the reaction of sodium metal and cold water, including state symbols. So sodium reacts with cold water to produce sodium hydroxide and hydrogen gas. The balance equation is 2Na in solid state plus 2HO, H2O in liquid state will give us 2NaOH aqueous plus H2 gas. Notice we need 2 sodium atoms and 2 water molecules to balance the hydrogen atoms produced as hydrogen gas. Moving on to part D. Part D asks us what term is given to the oxidized and hydroxides of metals. What name is given to the oxidized and hydroxides of metals? The answer is that they are called bases. What term is given to the oxidized and hydroxides of metals? The answer is that they are called what? Bases. If they are insoluble, if they are soluble in water, they are more specifically called alkalis. That brings us to the end of section A, which is question 8 with 6 marks.